This lesson is on functions, domain, and range. Before we can begin to understand functions, we need to look at relations, because functions are specific types of relations. A relation is a set of ordered pairs defined by the relation. Ordered pairs implies that there is an independent and a dependent variable. So an ordered pair always has kind of like an input, your x value, and an output, your y value. Your input is independent and your output is depending on the input. Now, if you look back at the definition, it's a set of ordered pairs, so some correspondence between an input and an output, as defined by the relation. So the relation indeed defines the correspondence between the two components. So an example would be houses assigned to postal workers. So say you've got houses, and so say there's a bunch of houses in a city here, and maybe some of these houses are assigned to a certain postal worker. So one postal worker has a few houses here. You can imagine that there would be more of these, obviously, but you can see that there's a relationship there between the house number and the postal worker number. Another example would be the time needed to get to UFV, to the Abbotsford campus, say, based on the city of residence. So say you had a class in Abbotsford and you lived in Abbotsford. Somebody could say, oh, hey, it takes me 5 minutes. Another Abbotsfordian could say it takes them 10 minutes. Someone from Chilliwack could say it takes them 20 minutes. Someone from Hope could say 70 minutes. So you can see there's a relationship there between the city of residence, which is the independent, and the time that it takes, which is your output. Yet another example would be the distance driven after a certain time at 50 kilometers an hour. So if we look at that, say, so the distance driven is our output. So say we were driving for 2 hours. That's our independent variable. Time is going no matter what we do. That's independent. So based on the 2 hours, that would mean that we have gone 100 kilometers. 3 hours would be 150 kilometers. Now these are all relations, but only some of them are functions. So you'll notice that when we define function, it defines something that can sort of be generalized. So if you look at the city of residence question, there's a problem here. There's a problem because a person from Abbotsford takes 5 minutes and another person from Abbotsford takes 10 minutes. So you cannot generalize that all people from Abbotsford take 5 minutes or 10 minutes. Do you see how that doesn't make sense? So a relation can still exist like this, but there is a problem with calling that a function. So let's just take a look at functions. A function is a relation where each input has no more than one output. So each input has a unique output. So if you have an input, it has one answer. Another input could have the same answer. That's fine. But each input has one answer. So here's an example with bus fare. So say you travel one zone, it costs you $3.25. Input, output. Independent, dependent. 2 zones, it costs you $3.50. 3 zones, it costs you $3.75. So this is a very nice relation. In fact, it is definitely a function because there is a generalization to be made for 1 zone and for 2 zones and for 3 zones. There is one answer for every input. So you can also say there is one answer, one unique answer to each input. And also the inputs, the set of all the inputs is called the domain. And the set of all the outputs is called the range. And remember, the inputs are independent and the outputs are dependent. So the outputs are always depending on the independent variable. So the price you pay depends on how many zones you've got. So these are examples of functions in particular. So notice that as soon as you have an input that has 2 answers, then it's not a function. But you can have an input that has 1 answer. You could have even 2 inputs that give you the same answer, and that's fine. There's also something called function notation. So once you know it's a function, you can use this notation, and it's often used, so it's best to know what it means. And the common misconception when you see this is to think that this is a times sign, and it's not. All it is it's read f of x, which implies function of x. F is the name of the function, so you could see something like h of x if it's a function of height in terms of x, or better yet, it could be height in terms of time. The thing in the brackets is always your independent variable. The thing out front is describing what the output is, the dependent variable is. So x is the independent, or the input, and f of x in total is the dependent, or the output. So a function can be referred to as an input-output system where every input has a unique output. Let's take a look at an input-output system. Here, the top line is representing input values and the bottom line is representing output values. So at 0, the output value is -2. At -1, the output value is -3. At -2, the output value is -4. We can also move up the scale. At 3, the output value is 1. And so on. You can play around. At 5, it's a 3. So what relationship would you say that the input has to the output? Well, as we can see, every single input is related to its output by subtracting 2. And so every time we take an x value, we subtract 2 to get the y value. This is an example of a function. Let's consider the following. Are these functions or not? So they're both relations. A relation is a broad term. They relate the x and y, the input and the output, the input and the output, the input and the output. So you could draw a mapping of this just to get a sense. So -3, 2, and 2 are the inputs. So that's actually your domain. So if you were asked for domain, you could say that the domain is -3, 2, and 2. So 2 doesn't have to be repeated. And the range is all your outputs, the black numbers. So 1, 1, and 0. So you could see that -3 goes to 1, 2 goes to 1, so that's okay. those both had one answer. And then 2 also goes to 0. So this is a problem because 2 is one input, but it has 2 answers. So we can't generalize this. It's not a function. Let's consider this other relation. So this one here has domain -3, 2, and 3. So we can map that out. And its range is 1 and 1 and 1. So you can see that every single one of these goes to 1. But that's fine because each one has a single answer. And that's what makes it a function. So each one has one answer, not 2 answers, therefore it is a function. So let's continue with some more examples here. So let's say you had f of x, function of x, as 2x plus 1. So is it a function? Does every input give you a single output? Well, if you were to make a table of values, as soon as you put one x value in, you'll go 2 times that x value and add 1, and you'll get 3 in this case. You could have 2, double 2 and add 1 will be 5. 3, double 3 and add 1 will be 7. So you can see that yes, it is a function because every time you put a number in, you're only going to have one answer. So let's just plot those points here. So 1, 3, 2, 5. You can see that 0 would be 1. And it looks approximately like that. Let's look at the other questions you might be asked. So if you see something like this, this implies find f, the function f, meaning the answer to plugging in x as 3/8. So all this means is it's an instruction telling you to replace your x value with the input provided to see what it equals. So 2 times 3/8 plus 1, so that'll be 3/4 plus 1, which is 4/4, which is 7/4. And that's it. There's no division, nothing else to be done. It is just saying evaluate 2x plus 1 with x being 3/8. Next, which x value will give you f of x equal to 0? Which actually means when does it cross the x-axis? Because f of x being 0 means the answer is 0, which is right here. You can kind of see it on the graph. So to do that, you would just say, well, what if my function 2x plus 1, the f of x, is equal to 0? Solve it. You get 2x is -1. You get x equals -1/2. And you can see on the graph it is at -1/2. What's the domain of f of x? Well, the domain, you can see there seems to be no restriction. It's going on forever. You can input any x value, so it's all real numbers. So you could either say all real numbers, or if you want to use interval notation, you could go -infinity to infinity, and that implies all real numbers, which is also written like that. So you can choose. What's the range? Well, similarly, you can get all answers. So again, it's -infinity to infinity. So let's look at some other examples. Here's one. Function g of x being x squared minus 2. So the question is this a function? Well, every time you put a number in, does it give you one answer or 2? That's essentially what the question is. So you could have x and g of x. So if you put a number in, say 1, that'll be 1 squared minus 2, which is -1. If you put in a 0, that'll be 0 squared minus 2, which is negative 2. If you put in a 2, you'll get 2 squared minus 2, which is 4 minus 2, which is 2. So also, you should already have a sense that a square will imply a parabola. So let's just plot these points and see if that's the case, which it should be. So 1, negative 1, 0, negative 2, 2, 2. And if you keep going, you will notice that the other points that you'll find are here. This actually tells us that the parabola is dropped by 2 places. So you should have a sense of the basic shapes. As soon as you see a square, you should know that it's a parabola. You will notice that this number here is telling you that all your values are being subtracted by 2. So a regular parabola would start here, and because you've subtracted 2, all the points have dropped down. So now the question is this a function? Does each input have a single output? You could kind of look at something called the vertical line test. Anytime you draw a vertical line, it should have no more than 1 point. Because if it has 2 points, that means that there were 2 answers for that one x value. So this one looks pretty good. So yes, it is a function. And what's the domain? Domain is all the possible x values, and you can see that you can plug anything in, square it, and subtract 2. So the domain is all real numbers. And the range is a little different because there are values you can get, but there are also values you can't get for y. So you can get 2, negative 1, 0, 1, 2, 3. All those points are satisfied. But these guys here, like negative 4, are not. So the range is actually everything from negative 2 all the way to infinity. What about this function? Have you seen this before? So think of what we could put in for x, because we need to be able to put something in for x and have one answer, always. So if we put something in for x, say 1, you'll get 1 over 1, which is 1. That's great. But can you think of a number that you can't put in there? That's right, you can't put a 0 in. So there is a hole in this graph, and that's at x equals 0. At x equals 0, there is no point. However, you can notice that there's a point at 1, 1. And if you've ever seen this before, let's just map it out a little clearer here. So let's say we put in a half, 0.5. Go 1 over 0.5 and you'll get 2. Because that's 1 over a half, which is 1 times 2 over 1. 1 over a third would be 3. 1 over a fourth would be 4. 1 over a fifth would be 5, and so on. Similarly, if you went forward the other way, you'd have 1/2 for a 2 and 1/3 for 3. So a half, a third, a fourth, a fifth. But you can imagine that this will actually never reach those points. So there's no way ever for it to reach 0, because it'll just keep getting closer and closer. Now, because there's no absolute value or anything on here, so we have all of these could be negative values as well. So everything that you had for this can also be placed with negative values. So this is the reciprocal function. So the question is it a function? Well, the only thing that would not make it a function would be if there were some spots in the graph where there were 2 answers to one x value. And that is not the case. Every single input has a unique output. So yes, it is a function. However, there are restrictions on the domain and range. The domain, you'll notice, does not include 0. Neither does the range, because you can't actually make this equal to 0. It will never happen. So, you could say, for example, in interval notation, it would be like negative infinity to 0, not including, or 0 to infinity. Or you could say, for example, they're all the real numbers except for 0, and list the points where it doesn't exist. Similarly, for range, it'll actually be the same. Now, what about this? So I've used y here, but the y could be an f of x. What if you have absolute value on your y? This is different than if the absolute value is on the x. If the absolute value is on the x, you can try it. There wouldn't be an issue. But since it's on the y, there's a little bit of an issue here. So what this means is if I choose an x, because that's the independent, so I have to choose that one and fix it. So let's say I chose x to be 1. So that means that my equation now looks like this. So what is my y? What can I possibly input in the absolute value to get 1? Well, y could actually be either positive 1 or negative 1, because you can take the absolute value of 1 or negative 1. And that's only because the y is absolute valued. So 1 could be 1, but it also could be negative 1. And there lies our problem, leading this to be not a function. Because one input gave us 2 outputs. And you can see if we start plotting these values, so 1 gave us 1 or negative 1. You'll see 2 would give you 2 or negative 2. 3, 3 or negative 3. And so it would look like this. Now if you pull a vertical line test on this, you can see that the lines actually cross at two points, causing it not to be a function. So it's not a function, but we can still state the domain and range. So what is the domain? Well, it's everything 0 or higher for x, because x is all the possible domains. So 0 to infinity, including 0. No negatives can go, basically, because you can't have a negative x, because then absolute value would be equal to a negative, which is impossible by definition of absolute value. So what's the range? Well, the range is essentially everything, right? You could have 1, 2, 3, 4, 5, negative 1, 2, negative 2, negative 3, and so on. So the range is all real numbers. So you may have noticed that the vertical line test that I was using is very useful. So relations are not functions if you have 2 or more outputs. So if you do this one here, is that a function or not? It's not, because of those 2 points. This one here, all the vertical lines check, it's fine. Here, all the vertical lines check except for this one spot where they're both 2 points for one input. So it's not a function. And here, this is fine up till there, and then you actually have 3. So it's not a function. So the only function is this, which is actually the same as y equals absolute value of x, or f of x equals absolute value of x. So you can notice that when the absolute value is on the x, it's fine, but when it's on the y, it causes an issue. So if the vertical line test is used, you can also determine if it's not a function if it crosses at more than one point.